Golf ball is struck with a velocity of 30 meters per second, 30 degrees above the ground, and lands at the same height that is struck. In answering the following questions, ignore the effects of air resistance. Draw a vector diagram, a vector triangle that represents the initial velocity of the golf ball, and hence calculate the initial horizontal and vertical components of the ball's velocity. Cool. So this is what my velocity looks like. 30 meters per second. Alright, 30 degrees above the ground. So we'll just split this into V, or initial, V, O, horizontal. Alright, so what were the equations for these? My VH is V cos theta, and my VV is V sine theta. Alright, so I'm going to just substitute those values in. So that's 30 cos 30, that is 30 sine 30. Now remember to have these in degrees, not radians. So my cos 1 becomes 26. My sine 1 becomes 15. There you go, done. B, calculate the height reached by the golf ball. Okay, my height, now what is it? Horizontal or vertical component? Height is kind of a vertical component. So we look at the VOV. So out of these values we found, we look at the VOV, which is 15 meters per second. So be careful what you write. So VOV is 15, so that's initial. Obviously my final, my final should be 0 at the maximum height. Should be 0. My A should be, gravity. What else do I know? I don't know time. S is what I'm trying to find, and that's just what I'm trying to do. Now T is missing, so I use an equation that doesn't have a T, which is V squared equals V naught squared plus 2AS. Let's sub those values in. So my S must be 15 squared, 2 times 9.8. So that would be 11.5 meters. So I just realized I'm missing a B, but let's see. I am missing a B. I'll have to come back to that one. I might just chuck it in there. So B was time taken. Sorry guys, I must have missed it when I copied and pasted it. B, time taken to reach maximum height. To reach max height. Okay, so not the whole time, just until max height. So let's do that one. So obviously this is going to be using the variables that we already had. So let's write some facts down. Alright, so my T is what I'm trying to find. My A is going to be affected by 9.8. My VOV was 15. What else? My S I don't know technically yet. My V should be 0 at the top, and this is what I'm going to be using now. The equation I'll be using, S is missing, so it's, V equals V naught plus AT, this equation. Sub those values in. 0 equals 15. Take 9.8 T. So T must be 15 divided by 9.8, which is 1.53 seconds. Right, so that's B. I just squeezed it in there. Let's move on. Calculate the range of the golf ball. Now, the word range hopefully triggers that you understand that it's a horizontal component. So you have to use the horizontal initial. So that's 26 meters per second over here. So just be aware of that. 26. range, so that's the distance. My time is the same. Now, just be careful. We've got time to get to the maximum height, so to get full time you have to times it by 2, because the whole range is the total time, which is, you know, once it goes up and then comes down as well, so you kind of have to times, so that's 1.5 seconds, 53 seconds, and that coming down is 1.53 seconds, so you've got to add them too. So it's 1.53 times 2 seconds because it's a round trip. Alright, the equation I'll be using is V equals S over T. Obviously rearrange to get S equals VT. So that should equal 26 times 1.53 times 2. So that'll be 79.6 meters. That is your range. Right, E, state the acceleration of the golf ball at its maximum height. Alright, so we're going to figure out the acceleration. Now, as again we've talked about projectile motion, doesn't matter where you are. Remember when we drew those vectors? Now A is just going to always be the same, negative 9.8, no matter what you are. So if I draw one at the maximum height over here, it's going to be the same, negative 9.8. So that's just simply your answer. A is negative 9.8. Doesn't matter where you are in the motion, it's always going to be constant at negative 9.8 meters per second. Right, state the velocity of the golf ball on impact with the ground. Now, again, my VH is going to be constant, right? It's constant throughout the whole motion, which is, I think, 26. Yep, 26. And this one doesn't change. But what we do have to find, is the VV. Alright, so that's what we're trying to find. So we can vector diagram and add it. A is negative 9.8. My velocity is 0. So technically we know every fact. I think, was it 4 seconds? No, it was around 1.53 times 2. 1.53 times 2. And what's the last fact? S we know as well technically. The maximum height. 11.5. So we know every fact technically. Alright, find the velocity, so I'm just going to use V equals V0 plus AT. That's just the easiest I find, because it's already rearranged. So my V is my V initial, which is 0, so I should have really had, hold on, what's going on here? Sorry, this should have been V0, my bad. I should have started with a V0, not V, because that's what we're trying to find. My V0 is over here, 15 meters per second. V0 V, 15 meters per second. Alright, so V0 is 15, my bad. Plus negative 9.8. And T, which is 1.53 times 2. Alright, so I better do all of that. And the calculator. I get negative 15 meters per second. Alright, so what you have to do is do the vector diagram to figure it out. Alright, so my horizontal is 26. Alright, my downwards is 15. So let's figure this out. Well, my x, square root of 15, 26, which is 30 meters per second. Now we've got to figure out the angle. So that's tan theta equals opposite over hypotenuse. So my theta must be inverse tan of that number. Make sure it's in degrees. And you get about 30 degrees. Now, let's conclude my answer. I'm just going to do it over here. Therefore, my velocity is negative 15 meters per second. Oh, no, that's not it. Sorry. I read the wrong one. It's this one over here, 30 meters per second. 30 degrees below. From the horizontal, you go below horizontal. There you go. And that's question 2.